Um, so just a few reminders. All the web work will be due April 27th, next Monday, and then the final exam is on April 28th, next Tuesday. So it will be available on D2L all day, but the time limit is 3 hours. So this week is the final week, the last week of the for the course, and I'll try to do some more. I'll do some more examples for the last section today, and then we'll do some review, do some past exam questions on Friday. Yep, D2L. The final exam will be available on D2L. Any questions? Okay. So let's see. Let's look at this question. So this is web work. 5.1, question 5. So 5.1 is about area between curves. Now the question is, you're given the following function, y equals 30 over x cubed, y equals 5 over x squared. Question is, find the area between these two curves. From x equals 3 to x equals 9. Okay. All right, what do I do? Okay, so I want to draw and then find the intersection points. Let's try to sketch the graph. What does it look like? What is, for example, what does the first one, 30 over x cubed, look like? What does it look like? No. Do we know what 1 over x looks like? So if I ask you to draw the graph 1 over x, what does it look like? Yeah, so 1 over x looks like this, right? On the positive side and on the negative side. And any other functions that look like 1 over x cubed, 1 over x squared would be almost the same. So because I only care about the area from 3 to 9, so I'm only drawing the positive part. So let's try to rescale. this. Does it make sense what I just say? So 1 over x cubed and 1 over x, they look almost the same. I mean, the values would not be the same, but they look the same. And so, for example, the first one, 30 over x cubed, you can draw like this. And then the second one is 5 over x squared. It also looks like this, but there are two situations. I mean, if I draw the two functions, they will look almost like the same like this, but there are two situations. One is it could be like this, where there's no intersection. It could also be like this. Does it make sense? And how do I know which one is correct? How do I know which situations am I in? Let me repeat this. So there are two situations when you draw the graph. One, the first one is the two graphs are separated like this. Second possibility is this. They have one intersection. And how do I know which one is the correct one? I'm asking a very simple question. How do I know they actually intersect each other? Yep, you set them equal. So you want to find out whether they have intersection points or not. So you set the two functions to be equal. And then what? So how do I solve this equation? Yeah, how do I solve the equation? Yep, so you can multiply both sides by x cubed, or if you like, you can do the cross multiplication and get 5x cubed equals 30x squared. Is it okay? So as I say, you can multiply both sides by x cubed, or you can do the cross multiplication. And so 5x cubed equals 30x squared. What do I do next? Okay, you can divide by x squared. Um, well, okay, so it just so happened that in this example you can do that, but in general, so in general you don't want to divide something that has x in it. So what I would do is I would put the 30x squared on the left hand side like this. I can pull out 5x squared and then get x minus 6 equals 0. That means I have two solutions. One is x equals 0. The other one is x equals 6. And here's the reason why I say that I would try not to divide something that has x, because if you did that, you're gonna miss x equals 0. But then again, in this example, x equals 0 doesn't make sense, right? And why does it not make sense? So why do I not need x equals 0? it's not it's not part of the graph. So the function is not defined on the function is not defined at x equals 0. So I don't really care about this point. So x equals 0 is the intersection point. So that means the graphs of the two functions actually cross each other and they look like this. And this is 6. Does it make sense? So let's say my 3 is here. Say my 9 is here. How do I know which one is on top, which one is bottom? So for example, from 3 to 6, how do I know which one is higher, which one is the lower one? Yep, that's very good. So you plug 3 into both functions. So for example, if you plug 3 into the first function, you get 30 over 27. If you plug 3 into the second function, you get 5 over 9. So this is to divide by 3. So this is 10 over 9. So the first one is higher from 3 to 6. Does it make sense? So plug 3 into both functions and see which one is bigger. The big one is the higher one from 3 to 6. The smaller one is the lower one from 3 to 6. And so this one should be y equals 30 over x cubed. This one should be y equals 5 over x squared. You can try to do 9 as well if you want. But yeah, is that okay? So the area that I'm interested in is this part and this part. So I have two areas, two pieces. What do I do? What do I do? So how many integrals do I need to write down? Any ideas? No? Okay. Well then we'll move on to the next question if there's no one wants to tell me what's your idea. So this is web work 5.1 question 9. Okay, we should go back to the. So we need to compute two integrals. One is from 3 to 6, and then the second one is from 6 to 9. So for the first one, you would do top minus bottom, and then from 3 to 6, we know that 30 over x cubed is higher than 5 over x squared. So 30x over x cubed minus 5 over x squared. For the second piece from 6 to 9, 5 over x squared is higher, so you do the other way around. So 5 over x squared minus 30 over x cubed. And do we know how to compute this two integrals? So what do I need to do for these two integrals? Yep, so take the antiderivatives of 30 over x cubed and also 5 over x squared. And for the first integral, you plug 6 and 3 into your antiderivatives, and then for the second one, you plug 9 and 6. Make sense? I'll let you do that. That should be really easy for you. Any questions before I move on? All right. What was the last part I said? I say it's easy. So you just find the antiderivatives and then plug in 6 and 3 for the first integral. And for the second integral, you plug 9 and 6. And then I say that by now you should be able to find antiderivatives. So I say that's easy. That should be easy for you. And let's look at the next question. So this is question 9 from webwork 5.1. So given the following equations, and then you want to find out the area between these three things. What do I do? So first thing is to graph them. So for me, it's easier to see, to simplify these the equations first. So for example, the first one, I'll get y equals 2 times root x. And then the last one is, that's a 2. And then the last one is y equals 4 minus 2x. Is it okay so far? And then I want to graph them. Let's look at the last function, y equals 4 minus 2x. What does it look like? So I'm asking, is it a line? Is it a parabola? Is it a hyperbola? Or is it something else? It's a line. So this is a line. Okay. And how do I draw a line? How many points do I need to know to draw a line? Okay, so give me 2 points on the line. Wait. I'm asking for 2 points on the line. So give me 2 points on the line. And what, Daniel, what did you say about 1 and 4? Are those x and y coordinates? So I need 2 points, and for each point, I need the x and y coordinates. One, 2, and 2, 4. Okay. 1, 2. 2, 4. This is 5. Well, 2 should be 0, right? So when x equals 2, y should be 0. Yeah. No, the whole question is once you draw the graph, find out the area between the two curves. So, so it looks like this. This is the second function, so this is y equals 4 minus 2x. And for the first function, y equals 2 times root x. What does it look like? Okay, a positive curve to the right. So we all know that square root function looks like this, right? So this is just the same as root x. And I also know that, yep, 1, 2 is a point on the square root function. So your graph for the root function looks like this. Guess I should draw higher. And the question is, what is the area between these two curves? Sketch the region enclosed by the curves given below. Decide whether to integrate with respect to x and y, then find the area. Yeah, let me look at the question again. So y equals 5, 2y plus 4, x equals 8. This is my graph. This is a really horrible question. So I think the question is asking, from my understanding is you want to find out what is this area. So you do need the y equals 5. This is y equals 5. Yeah, so you want to find out the intersection between all those lines. So this one should be maybe black. Yeah, that makes sense. So once you draw all the curves, including y equals 5, you want to find out the region enclosed by this 3 curves, which is what I drew here. So yeah, so right now, horizontal or vertical? So do I need to do horizontal or vertical? Okay, so again, let me ask you the question again. How do I know which one is better? How do I know vertical or horizontal is better? We mentioned last time that if I do horizontal, for example, like this, on the left side, the top function is y equals 5, and then the bottom function is y equals 4 minus 2x. On the right side, the top is y equals 5, but the bottom is y equals 2 times root x, which is a different function from what's on the left. Does it make sense? So if I were to do vertically, I would have to take the integration from 0 to 1 first, and then 1 to 2 separately. Does it make sense? So from 0 to 1, you'll be doing y equals 5 minus y equals 4 minus 2x, because that's a top and bottom function. And from 1 to whatever this is, which you need to find out, you're going to do y equals 5 and y equals 2 times root x. Does it make sense? Okay, I'm going to write this down. If I do vertically, area I need to do from 0 to 1. So the variable would be in terms of x, right? For vertical, it would be in terms of x. And from 0 to 1, you would do y equals 5 minus 4 minus 2x, because that's your top and bottom function. Plus from 1 to, I don't know what that is. That's something you need to figure out. That's this point. You're going to do 5 minus a different function, which is 2 times root x. Make sense? Whereas for horizontal, my box will look like this. And the right function is always 2 times root x. The left function is always 4 minus 2x. Does it make sense? And in this case, how do I write down my interval? So what is the lower limit and what is the upper limit? and which one minus which one? If I do horizontally, what is the upper what is the there's a lot of questions. What is the lower limit? What is the upper limit? Which one is the right function? Which one is the left function? Which one minus which one? So if I'm doing horizontally, what is the lower limit I can go? 2. So you can go as low as 2, and then what is the upper limit? 5. So you should put 2 and 5 here. And because I'm doing horizontally, everything should be in terms of y. So I need to change all my functions in terms of y. So I need to rewrite, for example, the first one, y equals 2 times root x in terms of y. So I need to put x in terms of y. Y equals 2 times root 2 times root x. So x equals, so x equals, yep. So 1/4 times y squared, and then the second function, y equals 4 minus 2x. And so x equals what? Yep, so 2 minus 1/2 times y. And so when you set up the integral, we know that the lower limit is 2, the upper limit is 5. But which one minus which one? So let's call this one the first one. Let's call this one the second one. Which one minus which one? First minus second or second minus first? Okay, 1 minus 2. The reason is, what is the reason? So when I'm doing horizontally, how do I know which one more to the left? Yeah, so you always, for horizontal integration, you would do right minus left. The right function is x equals 1/4 y squared, which is, I mean, the first function, and then minus the left function, which is the second one. So 1/4 y squared minus the other one, which is 2 minus 1/2 y. Is it okay? Um, so which one do you think is more? Which one do you think is easier for you? Okay. Um, well, but you still need to find out what is the upper limit here, right? So in this case, you can do vertically and horizontally, but you need to know how to do both. And I will actually think that in this case, horizontal is much easier because I don't need to find out what is the upper limit. And I need to be careful, for example, which function do I need to use? Um, but then again, so there are situations where you can only use horizontal, and there are situations where you can only use vertical. Um, so you need to know how to do both. That's what I'm saying. Is that okay? Any other questions? Any questions? All right.